Hi. Hi, today we shall be developing Johansen test of cointegration. And we have three variables such as x, y, and z. The variables are here. I can show you x, y, and z from 1960 until 1995. Right? We have three variables x, y, and z, and we as and but in Johansen test, variables must be non-stationary at a level, but when I convert them into first difference, they must be stationary. So that is always guideline, and we assume that our three variables such as x, y, and z, they are non-stationary at level, but when I convert them into first difference, they will become stationary. But here I have not tested it. I just assume that our variables x, y, z are non-stationary, and but if I convert them into first difference, they will become stationary. That I assume. So we can run the Johansen test now. Okay, how to proceed with the Johansen test? So we have to go to statistics, right? Then time series, not time series, we have to go to multivariate time series. Then you have to go to cointegrating rank of a VSM, right? We have to click here, and we have to choose the variables. So we have the three variables x, y, and z, and here I take maximum lag. So here I put 5 lag, right? I put here 5 lag, and trend specification, there are many options. I choose constant, and here we assume that our three variables x, y, z, they are non-stationary, but if I convert them into first difference, they will become stationary. That I assume, meaning that here all the variables x, y, z are the original data, initial data. That means data at level, initial raw data, and they are non-stationary, right? And time settings, I have to set the time also. So this is our variable. OBS means observation, and I select yearly because our data is yearly. Then I press OK. Okay, so we are set, everything is ready. Then I click OK to proceed. Okay, here I think I have okay, here is two things. Okay, here actually, okay, what I'm doing, I am running the model again. I'm running the model again because I go to statistics, okay, and go to times multivariate time series. Then I go to co-integrating rank of a VCM. Okay, then we have three variables, right? And here I have taken 5, and here I click on the reporting, right? I click on the reporting, and here I select this one, report maximum eigenvalue statistics, that I select, right? That I select also. Then I press OK. So this is our outcome. You can see we have three variables and Johansen test of co-integration, and you can see our things. Okay, and here there are few things. There are trace statistics, and there are 5% critical value, and there is maximum rank. Okay, so first we check what does mean by 0. 0 means that is also, I'm sorry. Okay, here I put 0. 0 is also, I can call it null hypothesis, meaning that there is no co-integration among variables. That is a null hypothesis. And what is alternative hypothesis? There is co-integration, right, among variables. So that is alternative hypothesis. Okay, and here, okay, so the first our first null hypothesis is 0, right? Okay, so the first we start with trace statistics, right? Okay, here our null hypothesis is 0. 0 means there is no co-integration among our three variables x, y, and z, right? That is the null hypothesis. And what is the guideline? The guideline is when the trace statistics is greater than critical value, we can reject null hypothesis, meaning that we can reject this one and can accept alternative hypothesis, meaning that there is co-integration. But if the trace statistics is less than critical value, we cannot reject null hypothesis, rather we accept null hypothesis. So that is the guideline all the time. And here we have null hypothesis 0 and also 1, also 2, and also 3. Okay, first I check with 0. Okay, here our value of statistics is 28.70 and critical value is 29.68. So statistics is less than critical value. So we cannot reject null hypothesis, rather we accept null hypothesis. meaning that we accept 0, meaning that there is no cointegration among variables, meaning that our variables x, y, z are not cointegrated, meaning that they do not have any long run associationship, or or they do not move together in the long run. So, and what is the guideline normally? When the variables are cointegrated, then we can run the vector error correction model, meaning that VECM model. But when the variables are not cointegrated, then we can run only var model, meaning that we can run unrestricted var model. And here our variables are not cointegrated, so we cannot run VECM model, but we can run only unrestricted var model. That means vector autoregressive model that we can run. So this one is the decision from the trace statistics, right? That is the decision of the trace statistics that we can run unrestricted var model. Okay, but we have one more test, that is Mak Statistics, right? Okay, we have Mak Statistics, and the method is same. The 0 meaning that there is no cointegration, and 1 means there is one cointegration, 2 means there is 3, and 3 means there are 3 cointegration. Okay, here, okay, so first I start with 0, meaning that there is no cointegration. Okay, the value of statistics is 21.78, which is more than 20.97. So we can reject the null hypothesis. So we can reject 0. So we can come here immediately, right? We can come here immediately. Okay, now I check about this one. That means there is one cointegration, right? Okay, and what is statistics? 6.84. And what is critical value? 14.07. So 6.8 is smaller than 14.07, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is one cointegration, meaning that our 3 variables x, y, and z, they are cointegrated, meaning that they have long run associationship, meaning that they move together in the long run. And what is the guideline? When the variables are cointegrated, we can run the vector error correction model. Okay, now here is a problem. What is the problem? So according to that trace statistics, variables are not co-integrated. So we cannot run vector error correction model, but we can run unrestricted var model. But according to Mak Statistics, the variables are co-integrated and we can run vector error correction model. Now that is the problem, that which one we should choose. Which one we should choose? So that is that dilemma now, right? But normally what happens, so it is up to the researcher to decide, right, which result he will accept, right? Either trace statistics or Mak Statistics, right? And it is completely up to you, right, to decide that which decision you will take. So that is a dilemma, right? But the best thing would be, when both are giving the same decision. So that is more secured, right, to decide whether we should run unrestricted var or VCM model. So actually it is up to the student, up to the person to decide, right, all the time. So the thing is, I am telling again, it is up to the researcher to decide which result you will accept, either trace statistics or Mak Statistics. But my opinion, best would be when both are giving the same decision. That is more secure to decide whether we should run unrestricted var or VECM model, right? So thank you very much for being with me for a while.